dealing with the interoperability between public administration, business, and also citizen. This is the last year of this 5 years program, and one of the focus of this year and the coming year will be indeed the co-innovation and data ecosystems. And in fact, we will also invest this last year a lot, and we will have probably additional contract in this direction. Indeed, the workshop of today, it's something that for me is very special, because we have not only a landscape of co-innovation, but also we have some good example of public and private sector data ecosystem collaboration. So, I'm also conscious of the time. I won't say more. I think I will leave the floor to Ray, that will introduce the goal of this workshop. And also, I would like to welcome again not only the participants, also the speakers that accepted to give their experience and to this event. Thanks. I leave the floor to Ray, and I hope you will enjoy this workshop. Hello, Ray.
Good morning, everyone. I'm Ray Boguslavsky. I'm an external consultant working with the Joint Research Centre. And this workshop today is on co-innovation with public-private sector data ecosystems. So we start with some presentations on the landscape for co-innovation, the key trends on location intelligence and the technologies involved, and secondly, how healthy data ecosystems and collaboration fuel innovation. So that's an introduction, an overview, and we have 4 really interesting case studies from different organizations in different situations. So I think you'll find all of this very interesting. We'll have question and answer, short question and answer after each presentation if you want to take the opportunity. So please raise your hand or put something in the chat, and we'll round up at the end with some collective thoughts on some of the key themes. So that's today, and I hope you have an enjoyable and interesting session. And I'll first hand over to Guido.
Yeah, thank you very much, Ray. Hi, everyone. I'm Guido van der Harst. I'm Senior Managing Partner at Gartner, responsible for the consulting engagements that we execute for public sector organizations based in the Benelux countries, Germany, Switzerland, and Austria. So really happy to be here today. And with me is my colleague, Clémentine Vallier. Clémentine, you can introduce yourself and get the presentation going.
Yes, thank you, Guido. I am Associate Director in Gartner Consulting based in Brussels. I'm focusing a lot on EU studies, and I lead innovation and interoperability work for public services and also EU policy. We've been accompanying JRC for a long time now, and we wanted to, let's say, set the keynote for today's seminar by focusing on how a technology-driven innovation is actually impactful in terms of transformation. So Guido will run through a series of technology trends that shape location intelligence. And this also introduces the notion of healthy data ecosystems that will be the main theme of this workshop. Without healthy data ecosystems, location intelligence, let's say, will not be, let's say, maximized in terms of impact. Thank you, Guido. I think the floor is yours now.
All right, well, thank you, Clémentine. So if we look at location intelligence, so what we actually talk about, and our definition is that location intelligence is the process of deriving meaningful insights from geospatial data relationships. And this not only concerns people, but also places and things as well. And the picture that you see here on the screen is the Gartner model for a digital platform, and it combines 5 different areas. So let me just quickly go through them and see how location intelligence fits into this model. So on the bottom right, you have the IT systems. So these are the legacy systems, the administrative systems of organizations that hold all the transactions that are available. Then on the top right, you have the ecosystem. So these are the systems that interact with third parties, the partners of the organization. Then you have your customers, the different websites for communicating with citizens, civilians, but also clients. And more importantly, on the bottom left, we have things that are, let's say, sensors out there in the field that provide a lot of information, for instance, on the flow of traffic, on temperature, on wind speeds, but also on location of things. For instance, a lot of people nowadays have smartphones. These smartphones know where they are, and that information is, through different channels, actually available. And what then in the middle you see intelligence, and that's the technology, the ability to combine all that information into meaningful insights. And why is location intelligence nowadays so important? Because it enables us to add context to the information, enriching the information with important contextual information. Now, if we move ahead and look into the trends that we believe will shape location intelligence over the coming years, we see the following table. Now, before I go into the different trends, maybe first some explanation where these trends come from and how at Gartner we deal with trends. What we have is a model, what's called the hype cycle model, where we follow the different trends. And when a trend emerges, it's like in the trigger stage. There are only a few parties that are actually using the trend. And when a trend becomes more and more relevant, more and more interesting to other parties, it usually reaches what we call a peak of inflated expectations. If you look, for instance, at the internet as a trend, around 2000, that was at the peak of inflated expectations. And then what happened? The bubble bursted and internet went through the trough of disillusionment. Now, 2 things can happen. A trend can either disappear or it can slowly reach a more productive state. It goes on the slope of enlightenment. And that's exactly what happened with the internet, where parties did find meaningful ways of applying the internet. And in the end, it reached what we call the plateau of productivity. So this is where most organizations are using the technology. So when it comes to trends going through that hype cycle, what you see is that some trends go very fast, reaching mainstream adoption, and other trends take more time. And that's depicted here in the different columns on this slide. So on the left-hand side, you see the trends that we believe will become mainstream within 2 years. And on the right-hand side, it probably will take 5 to 10 years before there is mainstream adoption. Does that mean that you should not apply those trends on the right-hand side? No, not necessarily so. What it means is that if you start, for instance, looking into GeoAI or in digital twins, that you probably have to take more effort in it, that you take a higher risk, that there's not that much knowledge available in the market, that you're a pioneer in applying those trends. So if you are a risk-averse organization, if you want to ensure that your project will be successful, those trends are probably less interesting for you to look at. On the other hand, that if you like to be at the forefront, if you like to invest in things, if you're willing to take risks, these are more interesting to look at. Then also the impact that trends have are different, and that assessment is depicted here in the different rows. So in the transformational axis or row, that means these are the trends that will have a profound impact on the way organizations are being organized. Then the high impact entails that probably processes will change in the way organizations work. And finally, the moderate trends that we depicted here are more, let's say, efficiency gains or just an improved way of working. Now, if we look at the trends themselves, the trend hard to miss here, it's really in bright orange depicted here, is cloud services for government. How exciting is that? What we saw over the last couple of years, that specifically business, commercial organizations were moving towards the cloud, but now we see also government organizations picking up on cloud services. So cloud services is having computing resources or complete applications or storage facilities not on-premise, not under your own control, but provided in the cloud, somewhere on the internet, as a service to you. Well, first, government organizations were very reluctant to apply those. What we see nowadays is that the major cloud providers can ensure that data is stored within certain geographic boundaries, and also the let's say risk of security that was perceived by government organizations is now also slightly taken away. And as a matter of fact, most of those cloud services are quite secure, sometimes even more secure than what you can do yourself. So why are cloud services interesting? For two important reasons. So not because it will save you money, probably won't save you money, probably will be more expensive, to be honest. But what it does provide you is a lot of flexibility and a very high speed to market. So it enables you to apply new technologies relatively fast than if you would have to run everything within your own data center. Now, some of the trends I like to highlight here with you include the geocoding services, which are processes or operations to transform location descriptors or descriptions like coordinates, addresses, or place names into actual map locations. These services are available from third parties. You can leverage them in your own solution, and it will enable you to actually put a specific location onto a data point that you have. Another important thing for building location intelligence are web mapping tools. And these enable you to actually visualize the data that you have onto a map. There are various providers out there that provide that. There are various examples that use that web mapping, those web mapping tools as well. If we go one column to the right, a trend I like to mention here to you is the IoT event stream processing technology. This is about all those different sensors that are out there in the field transmitting data, require some powerful technology to be able to process it and to make sure that it's channeled in the right direction and that it leads to meaningful insights. This is something that is important and where we see more and more solutions coming up. If we go a little bit down in the list, a trend there is open data and APIs. And especially the APIs, the application programming interfaces, are really important for building location intelligence as you want to connect to different sources. And the APIs are, let's say, the gateway to those different sources. APIs have been around for a very long time. I mean, over 40, 50 years. But what we see nowadays is that they're no longer really dependent on the technology provided by a certain vendor, but that they are open and that it's a lot easier to connect to services than it used to be in the past. 3D 4D maps. 3D is introducing the notion of height, so you can actually see buildings and things like that. And 4D is about adding the time dimension to trends, so you can actually see the changes over time evolve. And then if we go to the 5 to 10 years, GeoAI is like applying artificial intelligence on geographic data. Very interesting. I have an example of that on the next slide. Digital twin is building a replica of, for instance, a city in the digital realm, and then start looking at the impact of making changes, for instance, in roads or certain configurations within the city, what that will do to the flow of traffic. So basically, it's simulating changes that you want to test drive before actually applying them into practice. Digital twins originally come from, let's say, simulation techniques, but we now also see more and more examples of organizations and governments, like for instance Singapore, applying this for their own city. I think these are the key ones I like to highlight here. Let me quickly, because we still have some time left, give you some examples of where this could lead to. And this is something that's in the process of being developed at the moment. The European Commission, they provide subsidies for agricultural, for farmers growing certain crops, etc. And it's up to the local governments to check if the right crops are being grown or not. And that takes a lot of, it's very labor intensive to perform those compliance checks. Now, what this does is that instead of sending people into the field, satellite images are being used to monitor if the right crops are being grown. It uses GeoAI to make sure, or to check whether or not the proper crops are grown. And the interesting thing is that it's now possible to monitor 100% of the agricultural parcels instead of the 5% that was possible through the on-site visits. And what we see here is a good example of taxpayers' money being spent in a much better way. Another example that has been around for a longer time is with the Gendarmerie Nationale in France. And this is about predicting where crime will happen and connecting a lot of different data sources into a location intelligence unit. This system makes it possible to predict where the next event is likely to take place. And that enables the police forces across France and also in their overseas territories to actually roll out to the right place and make sure and prevent actually crime from happening. And if they're there and the crime happens, they're already at the location. Final example I like to mention here is in the United States, the Storm Sense project that collects a lot of data from sensors and that enables the government to provide relevant data to citizens and organizations across the area before a flooding occurs. So that actually shows them what's going on, what the predictions will be, and if a flooding is likely to occur, all the different constituencies can take their let's say, precautions and avoid heavy damages from happening. That's it from our side. I trust you find this useful, and Ray, I'll give the floor back to you.
Thank you very much, Guido. That was very interesting, and it's good to see the examples as well as the mapping of the technologies. So a lot of fuel for thought there. I'd like to move on though and give the other landscape presentation, and then we'll see if there's any questions for both of us at that point, if that's okay. So I'll load my presentation.
Good morning, everybody. I'm Lisbeth Rambouts. I work for Information Vlaanderen, for Informatie Vlaanderen. I'm going.
Elizabeth, you sound a bit far away. Maybe you can move closer to the microphone.
Yeah, I work with the headsets, but
This is already much better. Yeah.
okay, I just turned it in my ear. I work for Informatie Vlaanderen, and we maintain and developed the cable and pipeline information portal in Flanders. We call it CLIP, Kabel- en Leidinginformatieportaal. We are first, our first version of CLIP was a central platform to apply for maps of underground cables and pipelines. It was a very decent system. You had one central platform, it was very useful, but the answers came a little bit in different formats and different styles. So we had, when you applied for a map, you got piles and piles of paper or CD-ROMs or even links to web pages. So you got different media. All the maps were of different scales, different like legendas, formats, or even base maps. The interpretation of such maps is time consuming. For instance, I applied for a map of my own street one day, and it took me half a day to interpret or even select the maps that were really from my streets. I got zones from kilometers down the roads as well. So the time, when the interpretation is time consuming and there's a lot of chance to have some misinterpretation, it's not that useful because it causes accidents to happen. We thought we can do better. We have a central platform. Now let's draft a business case together with the stakeholders to see what we can do about solving this problem. So we have a steering committee with members of the utility sector, like the Flemish Council of Utility Operators. We have some representatives of the construction sector. We have got 2 lobby groups of them, and we have local and regional authorities. And in the business case, we stated that the map requesters, most of them are contractors, they wish to consult all information in one map. So not any piles of maps anymore, it's just one map with all information on. And they wanted to shorten the time to receive the underground information. It used to be 15 working days in the old times, in the first version of CLIP, because all of it was sent by the mail. Nowadays, it's much more faster. They also wanted to have one legend. So it was the misinterpretation is very has lowered now, because every if they see a red cable, they know, oh, it's an electricity one. And they wanted to receive only the information within the requested zone. So you don't have to worry about data from miles away. You know the data you get is data in the zone you requested. The utility operators, on their hand, they wanted to manage and store their own information. We have 50% of our utility operators in CLIP are privately owned. So 50% public are public owned operators, 50% privately. And for the private companies, it was very important to own and manage their own data. They didn't want a central database with all the central register of underground cables and pipelines. They wanted to use open standards to exchange information. So they didn't want any proprietary standards to be used. And then it turned out that setting up a fully digital exchange was the way to go. We set up some working groups for the collaboration on the business requirements, or for example, the data model or the viewer, printing, archiving, some legal aspects, and of course the technical ones. The big subject was a data model. First thing we did was drafting the data model. It became our information model of cables and pipelines, IMKL. It's an extension of the Inspire utility services data model. We added some additional classes, properties, relationships. For instance, we added the color of a cable. When you're digging a hole in the ground, one of the first things you notice is the color, which color does that cable has. And we added some possibilities to add a cross profile of a pipeline and so on. Why did we choose the Inspire data model? Because many utility operators have to comply to the Inspire directive. So 50% of our utility operators have to comply. And they prevent that they have to convert their data to more than one data model, we used the Inspire data model as a baseline for the IMKL model. So we extended the Inspire model with the information that our stakeholders believed was missing and needed for our use case of preventing digging damage. And to set up this IMKL data model to help with the exercise of setting up the model, we used a prototype for really fine-tuning the requirements to let the stakeholders see what is possible. And the most important part of the prototype was to reassure utility operators that their network was displayed well. So after finishing up the data model, there was a lot of work to do at the utility operator side because they had to convert data from their operational database to the IMKL format. They had to they have to apply an answer for each map request. So for each map request, they have to select in their operational databases the data they want to share with the map requester, and they have to convert it to this IMKL. So which flow do we have now? We have a map requester that's requesting for a map. He has to pay for each map request because CLIP is fully financed by those map requests. The utility operators don't have to pay to use CLIP. It's the map requester who is paying because the utility operators, well, they had to convert their data and they have to pay for this. We don't convert their data. So the map requester requests a map in CLIP. We send the map request to all utility operators involved, the utility operators present in the requested zone. They send their IMKL answer to CLIP, and we concatenate that answer, and we add the Flemish large scale base map to those answers, and we make all that information available for the map requester. The map requester in this turn can view the maps in a viewer. We have an online viewer, or he can choose to use one of the apps. We have an Android, iOS, and Windows app for offline use. I talked about the data model we set up together with the stakeholders. But after setting up the data model, we've set up a common data model, common model for the symbology as well. So every team is one color, and the utility operators can't say, well, blue in my case is electricity, and blue at another utility operator, well, that's gas. So blue is always water now. If you want to make more of advanced use of the data, you can download the raw XML data the utility operator sent us, and you can use it in your BIM model or other use. And if you want more information about CLIP and how it works and so on, you can visit the link to our English website. It's a quite a condensed website, but it got a lot of information about CLIP in English. Or you can contact me directly by my email, or yes, try to come to the coordinates from this session. Thank you.
So great, Lisbeth. That's a very interesting and practical example of a data ecosystem with the different actors and the use of standards and a real practical purpose. Are there any questions for Lisbeth? No, if so, if not, I'll move on. And I'd like to run through the case study presentations before coming back myself. I'm still having problems. So
there was one question.
Okay. Question, please.
Hello, this is Antti Jakobsson from National Land Survey Finland. Thank you for the presentation. My question is that have you noticed any issues with quality when you deliver, or those operators deliver their data and you join them up? Are there any issues on quality?
Yes, there are issues on quality. I wanted to share my screen again. Yes, and the issues are mostly in advanced use. Well, we don't say to the utility operators, you have to locate your cables and pipelines within 30 centimeters from the place where are in reality. We came from far. There were utility operators who had barely had maps, or who had maps, but they were so old, they had to reinvestigate them. You had the utility operators with very nice 3D data, so for them it was not a problem. We have in our IMKL model, we have an attribute. It's an accuracy attribute. It's a code list where you have to say for each cable and pipeline how accurate the data is. So you have a notice of the accuracy. But what we see is if you import the XML data, for advanced use, if you import the XML data in a BIM model, the accuracy attribute is one of the attributes that's not imported. So, for instance, what you see now, the company where I got this picture from, they didn't import accuracy as well. So then it's becoming more and more a problem if the data is not that accurate. Problem with underground cables and pipelines is you can't measure, you can only measure them when the pit is open, or you can use ground radar systems or so on, but it's very expensive to measure or to locate the cables and the pipelines when there's no pit. So for many utility operators, for most of them who were the operating of the utility pipelines and it's not their core business, it costs way too much to relocate their underground assets.
Great, thank you, Lisbeth. I'd like to move on if we could, and move on to Ricardo.
Okay, so good morning, everyone. My name is Ricardo Vitorino. I work at Ubiware as Smart Cities Research and Innovation Manager. Let me just hide this over here. So to start with Ubiware, I'll be talking today about the use case in Guimarães, but Ubiware is a software development SME, Portuguese. And we develop software for telecom and smart cities, mostly working with data analysis, data collection, and solving specific use cases and challenges for operators, city service providers, and municipalities, among others. We are now working from home, most of us, but as soon as this pandemic is over, we are more than happy to welcome you to visit our offices and visit the lovely city of Aveiro. Our software is being run in more than 55 cities at the moment. So even though we are a small enterprise from Portugal, we are very ambitious and we leverage on research and innovation to exploit our solutions all across the world. And I bring here today one specific use case, the city of Guimarães in Portugal. It is known as, or often referred to as, the birthplace of our country, because it is widely believed that our first king was born here, and also due to the fact that an important event for the foundation of the kingdom was in fact fought in the vicinity of the city. It's a beautiful city which I encourage you to visit soon enough, located in the north of Portugal, less than 1 hour away from Porto, and internationally recognized as an example in the rehabilitation and preservation of its historic center, which has been distinguished as World Heritage Site by UNESCO. It's European Capital of Culture it was European Capital of Culture in 2012, and also European City of Sports in the following year. So it's been able to reduce its emissions of CO2 per capita in 2007, the European goal for 2020, but the city is more and more ambitious in solving specific issues regarding sustainability. And when we met the city, we asked them directly the question if they could imagine the city as a single integrated system. And it's really funny to see that some of the words I've proposed here today for the presentation has been mentioned by Gartner in the previous slides as trends for the next 10 years. So our idea is that in order to digitalize all the information that comes from different domains, different organizations, different infrastructure, could be IoT devices, smartphone apps, vehicles. If you use different applications to manage it and you don't have a central view and a holistic approach, it's difficult to manage a city with all the ambition and all the busy agenda that they have. So we proposed a solution called the Urban Platform that solves exactly these city challenges through an integrated approach, integrating data from different vendors, verticals, and standardizing the data collection with open protocols and standards. And I'll show you just a few of the value propositions. I hope the animated images work well on WebEx, but the city of Guimarães is able to integrate now different data sets from different domains in a single map, being able to see the real-time traffic flows, being able to correlate the traffic with the incidents that were reported by citizens, evaluating the parking occupancy and the charging stations of electrical vehicles with this information, being able to filter out according to the scope. So for an environmental agent, it's more important to see energy consumption and air quality emissions, not as much as the parking occupancy. For the transit operator, for the traffic manager, for the urban planner, they can filter out and see the data that they want, both in terms of real-time analytics, but the real-time data as well as on the map. But also on a large scale or a long-term analysis, we can also support urban planning. So the 3D maps that Gartner just mentioned is one of the features we brought into our platform because of its given added value for urban planning. But again, we are modular and flexible, and our end users can choose if they want to see the data in 2D or 3D, and soon enough in 4D, so that they can not replace what they have in different systems, geographic information systems, open data portals, but in fact integrate the whole thing as a federated system within the urban platform and be able to correlate it and filter out by administrative division, by district, by street, in fact, just analyze it according to their own needs. The idea is not just to collect data, but also engage with the community. So being a citizen-centric and data-driven solution, we aim at providing this bi-directional feedback mechanisms within the community. So we support the city in collecting feedback from the community. At the moment, mostly issues or problems that are happening in the street. And ideally, the solution is when the city acts upon, so that it becomes more effective on seeing where it is, what's the problem, and dispatch different units and have customized workflows for it. Whenever it activates and see the different stages of those incidents, the citizen receives the feedback, and it opens a communication channel with the two entities. So if someone reports a big issue, you can directly call the firefighter, or you can ask a technician to validate first. And in order to make these decisions and feedback more efficient, we promote customizable dashboards that allow for data-driven insights about the city. So you'll see that we can filter out days of the week, times of the day, and evaluate the different values of parking occupancy, traffic flow observations, understanding the correlation between the traffic within different times of the day, seeing if it was impacted by some sort of new policy or new implementation, allowing the city to use the data to validate their own policies and their own decisions instead of just leveraging on empiric or common sense solutions. So here they can really learn about the data on their own dashboards and on their own solution. But for the mayor, for the strategic planner, and towards the United Nations 2030 Sustainable Development Goals, we provide the standard quality of life and sustainability indicators, meaning that they can benchmark the city towards the Green Deal, towards the Paris Agreement, seeing if they are matching their own goals and comparing with other cities that comply with the same international standard. All this is possible because we are promoting a cloud platform that is very modular in terms of software and provides open APIs that allows for data that can come from IoT event streams, open data portals, vehicles, databases all across the city and from different vendors and different providers, making sure that if it works for Guimarães, if it works for these vendors, it works for different, and it allows for replicability and different scalability issues. So we comply with different open standards, which means that the protocols and the data models are common and harmonized amongst different domains. And this allows for best practices in terms of software development. For the city, it helps them map the information, take decisions, analyze policies, try out, and have on their own hands a digital twin that makes them more sustainable. Thank you so much for this opportunity. You can reach me out by email. I'm open for questions or discussing anything that I went too fast or wasn't so clear. And thank you so much for this opportunity.
Okay, great. Thank you, Ricardo. So a really good example of multi-purpose data ecosystem in a city context. Do we have any questions for Ricardo?
If they come up in the meantime, feel free to reach me by email. Again, I'm typically accessible, so just let me know if anything comes up or if you're looking for new partnerships. But thank you, Ray, so much for this opportunity and all the participants.
Okay, that's great. And now we move on to a very important topic, a very critical topic at the moment, and we're looking at COVID-19 and how data ecosystems and analysis of data is helping deal with the pandemic. So Javier, I'd like to hand over to you, please.
Thank you. Great. Hi, everybody. So I'm just going to share my screen. Just a second while I get started. We can confirm that you can see it just quickly.
Yes, Javier, perfectly.
Okay.
Great. Yeah.
All right. Well, good morning, everybody. And thank you very much for having me here. As has been mentioned, I mean, like we obviously live in, like a very like challenging moments, around the world, with COVID-19. And, we'd like to talk a little bit about use cases and the context of location intelligence to that. But even to get started, I think for anybody that has been on this industry for a while, I think it's fair to say that there's never been a more important time to be working on geography, right? To be working on this industry. I think location intelligence is one of the few tools right now that can really help us to fight COVID-19. We were, for the vaccines and other things. Social distancing has essentially made the entire society aware of the importance of understanding where things happen and why they happen there. Right? So it's in that context, like a strong responsibility for all of us, that we're working in this industry, to look at how we can apply our knowledge to help on this pandemic. So a little bit about, like ourselves. So say, my name is Javier de la Torre. I'm the founder of Carto. And like to tell you a little bit about the platform, and then a few use cases of location intelligence applies to COVID-19. And if we have time, even go through a little bit of a demo. So, but before that, talking, complementing how we vision, how we see, location intelligence. Very often we explain it on the difference between understanding where and understanding why. If you want to know where there's more COVID-19 cases, you will likely be using a BI tool, such as Tableau, right, to see things in a map. But if you want to understand, like you want to model the characteristics that makes a place more vulnerable to COVID-19, where there's more cases, if you want to understand why things happen somewhere, then you need to do location intelligence. And that's what Carto as a platform does. It's a location intelligence platform to help you understand why things happen somewhere. A little bit, from an overall perspective, very briefly, Carto is a platform made of different products, or different solutions. So one that's available as an easy to use a drag and drop tool on the web called Carto Builder, where I'll give you a demo later. You can also use the APIs and SDKs under the hood to build your own applications, what we call Carto Engine, or you can actually do very advanced machine learning models using our engines, Python notebooks. All of this, and this is probably what is this relevant to this audience, is also supported by a product we call Data Observatory, which is a repository of open and commercial data already pre-packaged and prepared and pre-indexed to be used within all these products. And you're going to see a few examples of that. Together with that, we have a spatial modeling engine to extract features out of these data sets. Those just going a little bit step by step. Since COVID-19 started, the pandemic, we knew that there was going to be a lot of demand for location intelligence platform. So we made Carto freely available to anybody that was working on fighting COVID-19, and the response has been huge. We provided more than 150 grants in 42 countries, many different projects around the world, looking at like the spread, looking at the mitigation, the vulnerabilities. It's been tremendous. So if you have any project around COVID-19, just so that we have this program. The other thing that we did, very important, is part of Data Observatory, this repository of data that I was talking. We have financial, human mobility, demographics, data already all prepared. But we also added a COVID-19 category, to include the kind of like the most important or useful data sets for doing location intelligence. Things like social distancing metrics coming out of different providers, things like retail impact scoreboard, things like what is the number of restrictions on mobility in different parts of the world. Those are all very important data sets if you're trying to understand the spread of COVID-19 or its impact on economy and society. So you'll see a few examples of that. So a lot of this, most of this data is actually freely available, so you can just use it straight away from our platform, from other platforms. Just thought about giving you just a quick demo, just very quickly about how to use our product. So this is Carto Builder, as I was describing. I'm already logged in. I'm just gonna go ahead here and create a new map. All the things that you do when you click in here, you can go and upload the data set. It's gonna put like a GeoJSON, in this case, based on somewhere on, in this case, on GitHub, about what is the number of cases on ICU, number of beds available on ICU in different states in the United States. I can say I want to update this every day, so it will automatically update that. And now Carto is going after that file, synchronizing it, downloading it, and Internally under the hood is there's PostGIS. We're one of the biggest developers of PostGIS, and well, and as you've seen now, it's imported in there. And in this tool, I can like zoom in. You can see here, like it's all the counties, and I can go ahead and like do some basics visualization. In case I'm just gonna kind of like change the color and do a color pleth. I'm gonna say like, okay, I want to look at ICU bed occupancy rate. Right? So I just got in here, and this is how quickly you can get a map. And this map, I can share it. I can like publish it, and many different things, and it will be updated continuously because every day Carto will automatically go on and synchronize the data. Right. That's just an example, a very quick demo of how one part of a product. Let me continue now. A little bit more on specific use cases around COVID-19. I have here a few selected. Like I said, like we've seen now many different places where you can apply location intelligence to COVID-19. So these are just a few of them. Very obvious, obviously, is understanding the risk of or vulnerability of different regions to COVID-19 based on population, age, things like health information, all those factors. You can use them to determine and create indexes to predict essentially, like which areas are more vulnerable and therefore likely going to have a bigger infection rate. That's an example here in UK. That's of course useful if you want to know how to deploy your resources or where you actually have to keep a special containment measurements. Another example, you've seen it in country after country in Europe and around the world. Countries are going now through the unlocking their economies by essentially going normally region by region. Those who can control the data, the location data, as smaller as possible, can open up parts of the country faster. And if they do it also in a transparent way, like it's more effective, for citizens. So in this case, like just by working with the government of Spain, looking at, like what are, like the different KPIs and factors that can be used to determine, like if an area can move to the next phase of unlocking, or not, right? So this like semaphore type of projects that you see now, I say in many countries around the world. That's another great example. Now going a little bit more analytics, one important thing that we are now moving from use cases that were more on the health side and the public like organizations, we're now going more towards, like the private sector, where, like the use case go more towards, like the economy, right? The crisis that coming that is getting started now. So one of the things obviously is, understanding, the association of these changes on human mobility after lockdowns with things, like what is the impact on, on the restaurants space, on retailers. And that's important, especially for large organizations who are trying to figure out, like what it's, or investment firms, for example, looking at which places are going to get more affected on the long term, on the short term, etc. So those type of correlations are key, right? Of location intelligence, what it can enable. Other more kind of like I don't want to call it basic, but like very clear applications. Things, in the tourist sector, open up the beaches, right? So how do you do that, right, in a way that is safe? So you having more and more now managers looking at designing plans for opening them up by looking and analyzing, like how many people can you fit safely. That's on the area of what we call like crowd management or flow management. The same goes in the stadiums, how much is, the occupancy rate that you can have, not only where people are seated, but also why they are like exiting all at the same time. All these type of things, location intelligence provides a strong analytics capabilities for doing that. Now, another part of our product with, like I was saying, with Python notebooks, it's a product we call CartoFrames. It's a library for working again on Python notebooks. This actually can be used for more like machine learning type of use cases for what we call a spatial data scientist. So an example of that we're working on is with a big retailer with stores around the world. They need to have information about what are the restrictions in different places. And that's getting really hard because, like countries are applying those restrictions different from region to region. And if you have like many countries, like now understanding the impact across your entire position can be pretty tough. right? So they do this type of analysis where they rely on us providing this core data that comes from the public sector, in order for them to provide the measurements on their business. Right? So that's another example there. I think the last one that I have in here, we're working a lot on going back to the office. So indoor positioning systems allow us now to have around from 1 to 3 meters positioning within an or closed space within an office, and that we can use it by having custom applications for the office where we can keep continuous track of the position of the employees, and therefore use that to record the trace in the contact history of every employee. So if in case there's needs to do contact tracing for if there's any employees getting sick, right? So that's one example. But also what is the occupancy of different rooms? All of those things are essentially location intelligence problems, just in a much smaller space, but the same type of problems. I think that's everything that I have for today. I don't want to spend too much time. So hopefully that gives you a glance of what is possible to do with location intelligence of COVID-19. And I urge anybody that has comments or feedback around what else could we do, what data sets or what type of analysis you think will be interesting, can be helpful, just reach to me, please. Thank you very much.
Great, thank you, Javier. A very rich presentation there, and some very real things that you're dealing with. Any questions for Javier? No? Let's move on then, and thank you. And Ed, would you like to come in, please, and tell us about Google Mobility?
Okay, good morning, everyone. Ed Parsons here from Google. Unlike my colleagues Javier and Ricardo, you probably need no introduction to Google. Google's mission statement is to organize the world's information to make it universally accessible and useful. That's been the mission statement from the very beginnings of Google's history, and it's particularly relevant today when we're all moving around much less than we used to, but still looking for information. And we use geography specifically as a mechanism for organizing all this information that's published on the internet, the information that we create ourselves. And an important element to both that creation of data and the production of information is the mobile app, and particularly the Maps application that you may have on your mobile device. Here's Steve Jobs, well over 10 years ago now, introducing the iPhone, and one of the apps that he used to demonstrate the capabilities of the smartphone was a Maps application. Google Maps today is one of those applications that we have that has more than 1 billion users. 1 billion users who are using this as part of their day-to-day lives. Obviously, a lot less now than was the case before COVID, but of course, people will come back to doing that. From the perspective of the interface between the public sector and the citizens, I think it's really important to recognize this fundamental point. Citizens of whichever jurisdiction we're interested in are users of mainstream applications on their mobile devices. And they're also users as mobile device application users are citizens as well. So we're talking about a common community, and often I think we try to draw artificial borders or boundaries between the public and the private sector. In reality, we're talking about the same groups of people. They want to access the information. They may choose different channels to access that information depending upon what they're doing during the day, but they are still fundamentally the same people. So I think it's important to recognize that many of our users are looking for information that's created by the public sector. The public sector want to find channels to access their users. I also want to look at a slightly, I suppose, different focus on mapping, particularly from the development of the applications that we commonly use. Initially, when we started thinking in terms of mobility solutions on maps, we had a mindset, I suppose, that was very Californian suburban worldview in which everyone drove, and driving was the primary mode of transport. That was probably and still is the case if you live in suburban California, but it's not really the case in Europe. It's probably never been the case in Europe. Nevertheless, the tools that we initially designed were focused on providing mobility solutions to someone that drove. It was pretty much really just an evolution of what we did with satellite navigation systems 20 years ago. But of course, things have moved on, and we now recognize that it's equally important to support people that are pedestrians, the people who are choosing to cycle. Cycling is going to play an increasingly important role in mobility as we move forward, perhaps in a post-COVID world. Then, of course, there are the public transit systems of buses and trains and metro systems and perhaps ferries. All of those supplemented now by on-demand ride-sharing systems or traditional taxi systems with applications that allow users to access them very easily. It's key, of course, to recognize that most of those public transit systems are, to a greater or lesser extent, managed by public sector bodies. They are the operators of those systems. They create data products to make those systems operate. They also produce data products in the form of information about schedules, about the operation of those networks, about disruptions, and so on. And a key focus of ourselves and many other organizations in the mobility space is getting that information about public transit systems into the hands of the users. And that's really the focus of what I want to talk about. In many ways, I think the problem is highlighted by this single image. This is a bus stop somewhere in Eastern England. Not unusual as far as bus stops look, but a bus stop in many ways is an indication of the failure of our ability to really deliver on a user need. If you think about it, a bus stop represents the fact that we don't know as a bus operator where our passengers actually are. So we ask them to come to this particular location to find and meet a bus. And from the user's perspective, from the passenger's point of view, I don't know where the bus is. I don't know if the bus is necessarily running on time. I don't know how full the bus is, and will it take me where I think it's going to. So I go to the bus stop to try to meet the bus that may take me to my destination. The bus stop represents many questions, but not many answers. And it's a compromise to that lacking of information. If you think about it, the information that we're lacking there, actually we now have capabilities to fulfill. We have the information that we could use to connect passengers to mass transit systems much more efficiently than we have done in the past. You can begin to see that if you're lucky to live in an area that's kind of a dense, well-organized urban environment where you may have public transport systems that are reasonably well organized and publishing information frequently. And this is exposed in applications here like Google Maps in a very personalized form. This is what I would see at my local railway station here in Southwest London. And today I could see this information. The public transport system here in London is operating almost normally, despite the fact there are far fewer passengers. But it tells me in real time how the buses are operating, how the trains are operating, when the next train to take me to my destination is expected to arrive. So there's a rich element or rich set of public transport data systems that are coming from public sector bodies that we're really interested in getting access to, because our customers, the consumers, the citizens want access to this. And the types of data we're talking about are station or bus stop details, the published timetable or schedule information, fare information, often quite complex, depending upon the type of operation of the public transport system in a particular region. These are data sets that are canonical. They come from a public sector body, and that's the source of truth. So it's important to be able to identify that data accurately. Increasingly important are what we term real-time data sets, things like service alerts where there's perhaps this disruption or there's planned maintenance, and specific trip updates, so saying that the bus or the train that you're actually sitting on is either working to time or not. And those types of feeds of information are really important to maintain in a consistent and timely fashion. As you could imagine, those real-time data feeds, there's quite a lot of work that you need to do to make sure you can get access to that information consistently and quickly enough that it's sensible and means something to your end users, to the passengers. The scope of what's possible, I guess, is demonstrated here by this slide that you can see work we were doing in Sydney with the New South Wales government, who are the operator of the public transport system there. And not only did we have that schedule information and trip status information provided by the operator, we're also using probe data from mobile phones and information the bus operator can also provide us with to give a sense of how busy a particular bus is as it's moving along the route. We use something called AVL, or automated vehicle location information, that's coming from the GPS in the bus to identify exactly where the bus is, and now providing this information on how busy the bus is to someone standing at a bus stop. So it might be the case that the initial bus that you see may be very busy, but there's only another bus, perhaps only a minute behind it, that's much less busy, and it's worthwhile you waiting to make that trip on the later bus. That's quite a sophisticated use case. Actually, just by providing information to users above and beyond what you might see in a published timetable brings enormous benefits. This is an analysis by Kerry Watkins, who looked at carrying out a survey of passengers, and those passengers found a 2-minute perceived drop in wait times for public transport when real-time information was made available to them. This is a perception. It didn't mean that they had to wait less time, but by making the information available in real time on people's mobile devices, they perceived that the system was operating better. And if people perceive a system to be efficient and operating well, they're much more likely to use it. And one of the big frictions for people not using public transport systems around the world is this perception that, well, I don't know how well it's working, or I'm not sure how reliable it is. By providing this information, you remove that element of friction. It opens up public transit to more people. Of course, there are challenges, and I think this is the main point of me being here to have this conversation with you. There are challenges to using public sector information, not just in the sense of public transit information, but in using all types of public sector information within the commercial platforms like Google Maps. There's an issue of quality of the source data not being suitable necessarily for journey planning. Specifically, here I'm talking about the data models and the file formats that are commonly used for operators of public transit systems. These complex schemas they may use and develop aren't necessarily of the appropriate nature for the data to be onwardly shared. So things like TransExchange or NetX are way too complex compared to GTFS, which is a format that's more suitable for user-facing passenger information applications. And that's the same, I suppose, also if you look at perhaps the data models that you might have built from an Inspire perspective compared to the relatively simple cartographic models that you might want for background mapping on a website. Data licensing remains an issue, has been an issue for as long as I've been in the industry, and I remember working for the Ordnance Survey. Data licensing was an issue then, and I've seen it on both sides of the argument, if you like, specifically in terms of service and in attribution requirements. Often it makes it difficult because, as a developer of a web platform, you won't necessarily know who the end user who's using your mapping are or what they may be using that information for. And it's hard to be able to agree to complex terms of service where the sort of the workflows and the supply chains are much longer and more complex than you may well initially recognize. Indeed, it was because of data licensing that Google ended up pretty much creating its own supplies of geospatial data around the planet, and we maintain our own databases of geospatial information quite a lot. Scalability is an issue, particularly in terms of that time-dependent, real-time data sets where we're representing the world as it's changing on a minute-by-minute basis. How we get access to that data that's changing quickly is something that's a more complex solution. We are working to try and make those interfaces a little bit easier. A colleague of mine, Holly, who was originally going to be presenting at the conference before COVID, has been developing this tool which we have created to work with public sector organizations to provide an easier mechanism for sharing data with us and making sure that that data is correctly attributed and managed and informing us when data sets change. It's still a complex process, still no easy way of doing this, and we'd be interested in your feedback in terms of, what are the better mechanisms for making this process as seamless and as transparent as we possibly can. Okay. I think to finish off, I think what's really interesting is now looking at, I suppose, the other end of the telescope a little bit. Spoken very much on the user perspective on getting information into the hands of our users, but that information that we're collecting ourselves and where we're combining it with insights about how people are using public transit networks is also of value clearly to the operator themselves. And we're beginning to experiment and develop products and work out what's the best way to make these insights available back to the operators in an easy and open fashion. So here's an initial insight that we discovered last year from the analysis of users of the London transport system. We identified the most crowded route happened to be the Jubilee line between those particular stations, and on the Central line and on the Waterloo and City line, which is actually a very small route. That's probably the busiest transit network in London, despite the fact that it's actually the smallest. This insight information comes from our users contributing anonymously information about where they are as they move around on a minute-by-minute basis. And that same information, as part of our response to COVID, you may well have seen exposed in our community mobility maps, where we've looked at how many people are using public transport systems now compared to a baseline in the beginning of January. And here's some examples from two cities that I suppose contrast in the response to the COVID epidemic. You can see Paris massively reduced at the beginning of April from the normal service that was there in January, but then beginning to pick up when the lockdown began to lift a few weeks ago, compared to Stockholm, which, as we all know, had a slightly different approach to managing the lockdown. You can see there a more consistent, a reduced baseline, but with less of a change over time. So it's still early days for understanding how we can make use of this insightful information. We need to clearly manage and protect individual privacy in making these insights available. But it's an interesting capability, I think, where we're in this space, this overlap between the public and the private sector views of the same citizens. And on that point, again, I'd like to thank you very much for the opportunity of talking to you. Please feel free to put your questions in the chat window. I'll follow those up during the rest of the presentation. And of course, you're more than welcome to contact me. My email or my Twitter handle are there. Thank you very much.
Great, thank you, Ed. Again, another great practical example with some of the challenges and some of the analytical possibilities, as well as operational activities. we're drawing to a close now. I'd like to summarize and perhaps use my presentation, if you could load it, Lorena, to give a brief summary. And then we'll see where we are. So perhaps you could load this up.
But in display settings, you can probably select swap displays and it will change on the top menu bar. There's an option of swapping this presenter mode to the viewer mode, and I think it will help.
But you cannot see the slide right now?
We see the presenter mode, we see the slides, but
Okay.
with the notes and so on. So on PowerPoint, you can click on display settings and swap the screens.
On the top display setting.
I don't know where to find this.
No.
Okay, maybe I can just.
In the view you had, just press F5 or click on the presenter mode again on that tiny icon on the.
This one?
There, yeah, this one. And then you'll have a button on the top saying display settings. There, you click it, and I think there's an option to swap.
Okay.
Yeah.
Okay. Is that better?
There you go. Yes, much better.
Thank you.
So, I mean, this is where Ed's coming from. We've got the road navigation data ecosystem, a typical data ecosystem with multiple actors. The next slide, please. And a combination of static and dynamic data. So it's a real operational ecosystem. And move on. Next slide. And as Ed referred to, the importance of standards in this data ecosystem and the multiple standards that are involved. The thematic standards such as DATEX and GDF and generic standards such as Inspire. And this is one typical data ecosystem. So moving on. There is no definition, no agreed definition of a data ecosystem. And this is shared with you to bring out some of the things that I feel are important around the purpose of these actors getting together. And they're collecting together to generate value and some of the features that are involved there. So this is something you may want to look at and follow up. And moving on, next slide. This data ecosystem is one of many in the mobility sector, and there are many data ecosystems across all the different sectors. And these are at city level or regional level, national level, or multinational level. So this is a hugely complex array of data ecosystems with lots of different actors. So move on. And geospatial is fundamental in these data ecosystems, and SDIs need to evolve to support these different data ecosystems. But moving on, these ecosystems, and we've seen today, are there supporting particular purposes, particular innovations, and you see some examples here. And we've also seen that cities are a focus of much of the geospatial innovation, and the need for effective public and private partnerships. These ecosystems you see cut across public sector and private sector, and this collaboration is really important. So moving on. Francesco at the beginning introduced Elise and our ISA squared program on geospatial interoperability. We've been working on frameworks, on location interoperability, surveys and studies, and knowledge sharing, and developing particular solutions on topics that are related to this space. And if you could click, you'll see some of the topics here that are being covered. And some of the things that we've learned, and we'll move on to the next slide. Around these topics are summarized here. The importance of being use case driven and demand driven, both in terms of the data ecosystems and in relation to particular actors. The importance of collaboration and increasingly important public and private sector collaboration. The importance of cities and how cities are a pocket for innovation in geospatial. And very importantly, the implications for data frameworks to support these multiple data ecosystems effectively. And we've heard of some of the practical ways of dealing with this, but to support all these data ecosystems going forward, a lot of attention needs to be given to the national data frameworks, the European data frameworks, and the integration between geospatial and non-geospatial. And just finally, on the next slide, this introduces the European data strategy and its focus on integrating with businesses and the importance of geospatial in the series of data spaces that are being created as part of the strategy. We see a key role for Inspire in what's called the Green Deal data space, but geospatial is going to be significantly important across all of these data spaces. You'll be hearing more about this in other sessions in the conference, but I just wanted to introduce this to you here. So that's a very quick run through of a summary from a practical example through to the strategies in Europe on these topics. We've had some great presentations today, and I don't know how we are for time. I guess with it being 11:30, we don't have time for questions. Is that the case? Lorena? Karen?
I mean, if the attendees would like to be other 10 minutes, we can go through them.
Okay, well, let's maybe you could put up the Q&A slide and then just we could just focus on that. I mean, the point in my presentation is the implications for our data frameworks and for the SDI in Europe to support all these opportunities. And I'd be very interested in both the presenter's view, but also from the floor on what you see as the implications for SDIs in supporting these important data ecosystems. I mean, we've heard some points in the in some of the great presentations. Is there anything to add, anything particular that anyone would like to bring out?
If I may kickstart this, Ray. On our side, the process with Gimenez was very, very useful for us to learn a lot, because it was something that might not have been clear in my presentation. It was a co-creation process, and the city knows really well the scope and the geography and the citizen community, and the co-creation process of integrating incrementally the data went very well, and it's an ongoing process. Then it stopped. So we started small with 3 data sets. We validated the quality of the information. We assessed a better way to showcase. We customized some dashboards. This is the sort of solutions we tend to look more. Co-creation process, joining people together, because when you look at standards, when you look at the added value and the benefit for cities, it's clear, but there are hundreds of standards that might link or that link to smart cities. And when you have a busy agenda taking decisions to improve the quality of life of your community, either you have the support and the budget to have someone technical to support your process, it might be difficult. So again, this is a co-creation process that will help them as well. So on our end, we know the standards, we participate in ETSI, we follow ISO, we know geospatial standards as well. We have the technology from research and development. The city knows the data, knows the domain, knows the challenges. It's a win-win situation. So as long as we keep pushing these opportunities to bring in different stakeholders together, I think it's the best strategy to create this data ecosystem innovation. Cities do not need to have everything digital at the start. They can start small and then incrementally develop the solution together with the industry and the research sectors.
Yeah, that's great. Yeah, and the importance of agility there you brought out. That's great. Any other points anyone would like to bring up.
Yeah, could I just interject here? It's Ed here. I think part of the issues with SDIs in general is because of their breadth. It's often difficult to get that user focus that you really require to understand the needs of specific applications. So I think it's a natural issue that you're always going to have with a broad infrastructure like this. But certainly from a commercial perspective, having that real laser focus on what a user need is really important in understanding the actual data requirements.
Yeah, I like the laser focus there. That's definitely good.
If I may add on this, I mean, I think like COVID-19 in particular has also kind of like shown us maybe the weaknesses of like how data sharing has been working. I think like I think it's fair to say that we haven't, as an entire kind of like Europeans and the world overall, done a great job on managing data for COVID-19. There's I mean, it actually ended up coming with institutions, like public organizations. There's been many from like companies, organizations that have to come because governments have not been able to deliver the data in a way that was useful to citizens and to the private sector. I think for me that's a lesson learned. And in a way, when I look at spatial data infrastructures, going back to the laser focus thing, I think like overall the learning is we have to ensure to ensure that like public sector stops doing a spatial data infrastructure to a certain point. Focus on just managing the data, getting the best data, getting it updated, getting it clean, getting it interpretable, but not going even farther than that, right? And that's like sometimes maybe my fear is that we have like try to go too far, and then for companies like ours and from my perspective on the private sector, what we really want is the data, not so much a lot of the services provided on top of the data. Right? So I think there has to be a better split of what are the responsibilities of the SDIs and what it goes after, right? And that will make sure that will mean that then the public sector will produce better data that will be more useful, that will be more updated, that will be more interpretable, and then the private sector will make sure to make the data like useful in the way that like citizens and companies and society needs them. I think like COVID-19 actually has shown a lot that case.
That's great. Some very powerful messages there in terms of what businesses need in order to provide better products, but also to serve the public sector. And that is a circular thing that we're dealing with here. I'm conscious of time now, and I wish we had more time to discuss these topics, because there's some great but really important things that we're all dealing with here. And I think the focus on some great examples today shows the true importance of data ecosystems and location intelligence, and us all working together. So I would like at that point to thank everyone. To thank all the speakers, to thank attendees, particularly for putting up with some of the issues that we've had in presenting, but I think we got there in the end. So I'd like to say goodbye all, and I wish you a good remainder of the conference. Bye.
Goodbye.
Hey, thanks really for organizing this. Bye-bye.
Thank you.
Take care.
Thank you. Bye.
Bye-bye.
Thank you,
Bye-bye.
everybody.
Thank you.
Bye.
Bye-bye.